Hello everyone, I'm Z from the project collaboration pod. I'm going to introduce our hackathon project, Aurora QueryGPT. This project translates human language into SQL statements and also provides a way to execute SQL to query the Aurora database. My teammate Evan Chen and I have collaborated on this project, and we also want to thank Morley and the hosted LLM team for their support. As a front-end engineer, writing SQL was challenging for me, but I still need to use it occasionally for debug and analytics purpose. Thanks to GPT-4, I was able to write accurate SQL statements quickly with the help of GitHub Copilot. Later, it occurred to me that individuals from various departments might also benefit from this, so I had the idea of creating a web app that uses the power of large language model to convert human language into SQL statements. Now, I will hand over to Evan for an in-app demo.
Hello, my name is Evan. I'm going to walk through our demo. After I open the Aurora QueryGPT page, I see two sections. The left side handles natural language to SQL statement translation. Rather than using public tools such as OpenAI's API, we utilize a private LLM service developed by Morley's team. We feed a small part of our database schema to the private LLM service so that the model just have enough context. We have a dropdown that lets us to choose one of the three models. The default is Mistral 8X7B. We have a text box for us to enter a prompt using natural language to generate a SQL statement. For example, I can say, show me how many residential projects have been created since 2022. After we hit the submit button, it's going to return a query. Here, we see two more icons. One is for us to copy the SQL statement to the clipboard and use it elsewhere. Or we can also directly move it to the text box on the right side. The right side handles getting the data. So we created a separate endpoint in the backend app that executes the query and get the data from the database. This means our data is never fed to the LLM service directly. And also because the endpoint lives in the backend app, it comes with the typical benefits of authentication and authorization. In fact, only Aurora admins can execute this query. Moreover, this endpoint ensures the SQL statement we put here never modifies the database data and is open for local and test environments only for now. So here it's connected to the local database. This is correct because I'm running it from my local machine. And after I hit the run button, it returns me the result, 37 projects. We can also submit more complex query. For example, list the top 5 teams with the most users. Show me the team names and user counts. Again, hit the submit button. It gives me the query. And if I move it to the right side and hit the explain button, then the model will explain the query to me using natural language. Looks like in this case, we have a join clause to join two tables together. And again, hit the run button. It's going to return me the 5 teams with the most users. Next, I want to show we can do things iteratively. Here, I want to list 20 users with their name, email, team role, and tenant name. Again, I hit submit. I expect I will see a couple join statements because the data come from different tables. Sure they are. Hit the run button. But something is not quite right. Instead of returning 20 users, it only returns users on a team. But it's okay, it's live demo. We can fix that. We can add another sentence to the prompt. Also include users not in a team. Try again. And then copy. Now, you can see that you changed to use the left join and run it. It looks a lot better, 20 users, including those not on a team. Finally, I want to show it doesn't allow modifying data. If I change the prompt to change all the project address to this one, the model is nice enough to give me an update statement. But if I try to execute this one, the backend endpoint will return an error. This is the end of our demo. I hope you found it interesting.